Hello, we're Group 10. My name's Marcus,
My name's Johnny.
And I'm Zach.
and we'll be talking about cavitation today. Okay, cavitation is the formation of vapor cavities within a liquid. It usually occurs when a liquid is subjected to rapid changes in pressure that cause the formation of the cavities. These cavities are typically formed when the pressure is very low, and then when the cavities are subjected to high pressure, they will implode. These implosions will create shock waves of up to 100,000 pounds per square inch. But if we break down cavitation, we can break it down into two major sections, the inertial and the non-inertial groups. The inertial groups are the process where a void or a bubble in liquid is rapidly collapsed, producing a shock wave. That is what we'll be focusing on today. The non-inertial process is where the bubble or the fluid is forced to oscillate in size or shape due to some form of energy being inputted. Cavitation itself has a ton of uses. These uses include, but are not limited to, the extraction of material, emulsification, dispersion, degassing, diffusion, depolymerization, medical uses, and water purification. The majority of these uses for cavitation are not widely used because there are other options that are financially and material-wise more effective. One such example would be to use ionic liquid because it's more cost-effective than cavitation in regards of depolarization.
Now that Marcus has talked about the good side of cavitation, let's look at the bad sides of it. In some forms of engineering context, cavitation can lead to serious damage, and this is due to stress that results in an implosion. This surface fatigue on metals is called cavitation. And some examples of this is, let's look at propellers and pumps. Pumps and propellers move in a fluid that's low pressure areas that form as fluid accelerates under the pressure of propellers and pumps. When vapor pressure is reached, the fluid vaporizes and forms bubble gases. This is also called cavitation, and when the bubbles collapse, they create shock waves that can damage propellers and pumps. Another example of this is control valves. This can occur when pressure drops actually exceeds the sizing calculation that was done for the control valves. The change from a liquid state to a vapor state results from the increase in flow velocity at or just downstream of the greatest flow restriction. If the pressure of the valve ends up being above the vapor pressure, then the vapor bubble that formed will collapse and cavitation will.
We have a few glass bottles filled partially with water here, and we're going to hit them on top with the palm of my hand, which causes, this impact causes the glass bottle to move faster than the water, which creates a vacuum at the bottom. And this vacuum of extremely low pressure is then filled back up really quickly with water, and the momentum of the water moving at such a high speed breaks just the bottom circle of the bottle out. This reaction falls under the inertia type of cavitation, and even though this is considered a bar trick, this does not work well with any carbonated beverages. The carbon dioxide from the liquid fills the vacuums formed at the bottom of the bottle, and the inertial effect of the water is extremely dampened because this pressure difference is now significantly lower.
Do you not have enough water in it?
Could be.
Ta-da!
Yeah.